All right, hello everybody. Welcome to part 2 of the lecture for sections 1.1 and 1.2. Hope everyone's doing well today. So as promised, here is your meme for this morning. So you go ahead and take a minute to look at that, and then I'll give you a second to laugh as well. All right, now that you got that, let's move on to our next learning. So we're going to look now at an example of something that involves linear functions. So if you remember from Pre-Calculus I, we spent quite a bit of time studying linear functions. And you may also remember that I have a favorite character, a favorite person I like to use in these types of problems. So this may sound familiar to some of you. So here's the problem we're looking at. So the profit in dollars for one of Queen Bey's concerts, and they're using the variable P to represent that, is linearly related to the number of tickets sold for the concert. And they're using the variable T to represent that. So in other words, they're telling us that profit is a function of the number of tickets sold, so P of T. And if 15,000 tickets are sold, the concert's profit is $645,000. If 45,000 tickets are sold, the concert's profit is $1,995,000. And they ask us to do these three things. Number one, find the rate of change or the slope for the concert's profit and explain what it means in words. And they want us to include units in our answer. Number two, write an equation for the function P of T. And then number three, find P of 30,000 and explain what it means in words. And we need units there as well. Okay, so a few things I want to point out on this slide here. So first of all, notice over here, they have told us that our function is P of T. And remember from stuff we talked about in the last video that T here, because it's on the inside there, that's going to be our input. And then the P here, because it's on the outside, and it's the name of the function, that's going to be our output. Okay, so we need to keep that in mind as we're setting up our equation, calculating our slope, and all of those sorts of things. Okay, so what I'm going to do is I'm going to go to a blank slide here, and I apologize, as you're watching this, you won't actually be able to see the problem as we work on it. But you can reference back to the PowerPoint as I'm talking about it. Remember, the PowerPoint is posted on WAMAP, and or you can back up the video if you need to be able to see that. So for the first question here, so we were asked to find the rate of change or the slope. And you may remember, or hopefully you remember from your mathematical past, that our formula for slope is M, stands for slope. And even though we're not using x's and y's here, we can use that formula that includes x's and y's. So the y2 minus y1 over the x2 minus x1. Okay. And really another way to think about this is change of outputs over change in inputs. So if we look back at our problem, we were told that if 15,000 tickets are sold, the concert profit is $645,000. If 45,000 tickets are sold, the concert's profit is $1,995,000. And we were also told that, remember, that profit is a function of the number of tickets sold. And we said that tickets were inputs and profit was output. So that kind of tells us we can put together 2 points from the information we're given. So our 2 points would look like 15,000, comma, 645,000. Okay, and again, that's because if we input 15,000, we get an output of 645,000. And then we also have 45,000, comma, 1,995,000. Okay. And again, that's because if we input 45,000, we get an output of 1,995,000. So we go ahead and plug that information into the slope formula up above. So if you remember, when we are choosing what is our y2 and our y1 and our x2 and an x1, it doesn't actually matter. What's important is if I say choose this 1,995,000 to be y2, this 45,000 right here has to be x2. And that would make the 645,000 here y1 and the 15,000 x1. Okay, so then we plug this information into the formula up above. So we'd have 1,995,000. Oh, excuse me for that bad 5. Minus 645 all over 45,000 minus 15,000. Okay, and I'm going to pull out my calculator here to help me with this. So do that 1,995,000 minus 645,000. I get on the top there 1,350,000 over 45,000 minus 15,000 gives us 30,000. Can simplify now by dividing those two. I get 45 for our slope. Okay. But then the second part of the problem, or part of that problem, they told us to include units. So we need to think about what our units are here on our slope. And remember that a slope is a rate of change. So that means that our unit should be something, some units per some other units. And if we go back to the beginning here, and we look at these numbers on the top of our fraction, well, these represented an amount of dollars. And the numbers on the bottom here, this represented a number of tickets. So what we know then is if we use those units down here, that a 45 is $45 per ticket. Okay, using those units over units. And then we were also asked to explain what that means in words. So I'm just going to say that verbally if we think about what this means. Again, this $45 per ticket, that's our rate of change, our slope. So it tells us how things are changing over time. So what this is telling us is that a profit, since that's our output, is changing and it increases because the 45 is positive. So it's increasing by $45 per ticket or per ticket sold. That's how the profit works. All right, let's move on to part 2 now that we have that. So part 2 then asks us to write an equation for the function p of t. Okay, and because we're dealing with linear functions here, we know that that function is going to have the form of a linear function. And if we remember off to the side here, our general form for a linear equation is the y equals mx plus b. Okay. And here, of course, we're not using x's and y's, we're using p's and t's. So in place of the x here, I could put t's. In place of the y's, it'd be p's. And then m, if you recall, m stands for our slope. Okay, and we just calculated our slope in the previous slide. So our slope was equal to 45. That was at $45 per ticket. And then the value for B, if you recall, B is our vertical intercept. Sorry, I meant to write this here. Vertical intercept. Or in applied problems like this, remember the vertical intercept can also be our starting value. So I apologize, I'm going all over the place here. Okay, and so that'd kind of be like, in this case, our starting value would be when the number of tickets is 0, what the profit is. Now, unfortunately, we weren't given that information. However, we can find it by using one of our points. Okay, so I know that this, right now, we don't know what B is. I'm going to put plus B, and I'm going to write this over here. We know right now that our formula is looking like 45t plus some value for B. So we'll choose one of our points. I'm going to use the 15,000 tickets sold and the profit being 645,000. So I can set up an equation like this. $45 times 15,000 plus B. So we can multiply the 45 and the 15,000 and then subtract that answer from the 645,000 to isolate the B. And if we do that, it looks like we get negative 30,000 for B, which you might think at first a negative numbers doesn't seem to make sense, but let's also think about this. That's the value when 0 tickets are sold, and so we're saying the profit is negative, so hopefully that makes sense because if she hasn't sold any tickets yet, she probably hasn't made any money, and there might be some cost for setting up the concert or something like that. So it looks like if we use that value now, then our formula ends up looking like P of T equals 45T minus 30,000. Okay, and that would be our formula there. Okay, so that's the answer for number 2. Let's now look at number 3. So number 3, we're asked to find P of 30,000 and explain what it means in words. Okay, so first of all, recalling what our function notation means, the P of 30,000 means input 30,000 for our input variable, which, if you recall from the last slide, our input variable, our input variable is T, number of tickets sold. So that 30,000 is representing a number of tickets. Okay, so we'll put that in for T in our formula. So we'll have 45, that's supposed to be a 45 times 30,000 minus 30,000. Okay, and recall when you do order of operations here, you need to multiply first before you subtract. So do 45 times 30,000 and subtract 30,000. And we end up with 1,320,000. And the problem reminds us to think about units. So if we remember, if the inputs are tickets here, the outputs are profit, which is measured in dollars. So this 1,320,000 is dollars. And again, we're asked to explain what this means in words. So what this is telling us is that when we input or when we sell 30,000 tickets, the output or the profit is $1,320,000. Isn't this fun? Gosh, I've missed math over spring break. Okay, so that's for the linear functions one. Let's move on to another problem now and talk about solving quadratics. So even last quarter in Math 142, we talked about several different ways to solve quadratic equations. So I'm going to go over one method here, but I will talk about what all the possibilities are. First of all, I want to discuss how we know this is a quadratic function or a quadratic equation. And recall that we can tell that by looking at the exponents here. So we notice that the highest exponent in this equation is a 2. And so that's what tells us this is a quadratic. And recall that generally when you're trying to solve quadratics, the first thing you want to do is set the equation equal to 0, which is what they have done here. If this had been something different, like say something like 5p squared minus 2 equals 3p, well, we would have wanted to have moved that 3p to the left-hand side so the equation was equal to 0 before we began solving it. But in this case, it's already been set equal to 0 for us, so we don't have to do any extra work on this. We'll also want to talk about our different methods for solving this, and we have 3 primary ways of doing this, or actually 2 primary ways, I should say. So one way to solve this, if we can, is by factoring. Okay, and the reason I said just a second ago that we had 3 ways to do this is I was thinking of the 2 different ways to factor. That's supposed to say factoring. So remember, we can do kind of factoring in what's called like unfoiling, which is basically just undoing something that's been foiled. Or we also have in a case like this one where the leading coefficient is not a 1, so we have this 5 here. Okay, in cases like that, we'd have to use a different factoring method. One that I like is what's called the AC method. If you're not sure what I mean when I say that, I'm happy to talk to you about that during class time, on Zoom, or during an office hour. Okay, so that's the first thing we want to try, and generally, if possible, we want to try to factor first. But if factoring doesn't work, then our other option is to use the quadratic formula. Okay, so that's the other way you can solve this if you don't want to factor. So looking at the problem we have here, it looks like it might factor. It's hard to tell though because of this 5 out in the front. So I'm going to go ahead and use the quadratic formula to solve this. If you recall, the quadratic formula is given by negative b plus or minus square root of b squared, it's supposed to be a squared, minus 4 times a times c, all divided by 2a. Okay, and it's very important that when you divide by 2a, it's that whole thing on the top divided by 2a. And recall that the values a, b, and c, those come from the formula up here, the equation. So the 5, the coefficient here, that'll be our a. Lord. Apologize, having troubles with the stylus still, trying to figure this out. There we go. There's the A. There's the B. And the -2 is the C. And recall when you plug these in, those are just the coefficients that are going in. You're not plugging them in with the variables. So plugging this in using the quadratic formula, we would end up with negative of 3 plus or minus square root of 3 squared minus 4 times 5 times -2, all divided by 2 times 5. And then we can very carefully work this out using order of operations. For the sake of time right now, I'm not going to go through that step by step. But if we do, using the plus on the top, it looks like we will get 2/5 as one of our answers here for P. And then if we use the minus, looks like we get -1 for P. So those would be our two answers there. Cool. All right, a couple more problems I want to go over here. So go back to some stuff from last quarter from Math 142, evaluating sine and cosine values without a calculator, which probably means they want us to do some exact values here. So looking at this, we have sine of pi over 6. Whoops. We have sine of pi over 6 and cosine of 5 pi over 4. And if you recall, pi over 6 and 5 pi over 4 are both values that lie on the unit circle. And if you remember, pi over 6, that is in the first quadrant. Pi over 6 is up here. 5 pi over 4 is in the third quadrant. So down here. And if you recall, on the unit circle, we find the sine and cosine values by looking at the x and the y values associated with the point at that particular angle. So at pi over 6, remember, our x and y values there were root 3 over 2, comma 1/2. And remember that sine is the y value. So here we have the sine of pi over 6 is 1/2. No, maybe it's 1/2. Come on, stylus. Okay. And then cosine of 5 pi over 4, so looking at 5 pi over 4 down here, since that's one of our pi over 4s, it's going to have root 2 over 2, comma root 2 over 2. They're both going to be negative because we are in the third quadrant. And cosine is the x value there, so we know this is negative root 2 over 2. So that's just a quick trig review for us. And the final thing from this PowerPoint here, solving a trig equation without a calculator. So we're still going to be using our unit circle here. Also note that they want us to find all values between 0 and 2 pi. So we're just looking at values on the unit circle here if they come out to be that. So first thing we need to do, recall, in order to solve something like this is isolate the cosine term here. So isolate the cosine of theta. So we can do that by adding 1 to both sides. of our equation. So we'd end up with then 2 cosine of theta equals 1. And then we can divide by 2 on both sides. So we'll end up with cosine of theta equals 1/2. And so to find the values for theta here, we need to think back to our unit circle, kind of do the opposite of what we did on the last slide. Think on the unit circle, where is cosine equal to 1/2? And because it's a positive 1/2, we know those answers are going to be in the first and the fourth quadrant. And remember, in our unit circle, we know that those values would be at pi over 3 and 5 pi over 3. So those would be our answers there. All right. Great. So that is it for this PowerPoint. So thank you guys all for watching, and good luck with your work. Bye.